Hello, morning guys.
Hello.
Hey,
Yeah, let's wait for a few minutes for folks to join.
okay.
Joseph, do you have anything to present? Like, if you want to present anything, like you can share the screen, see if that works.
I don't have any slides or anything, but the doc is there.
Yeah, or like see if you can share the doc.
Okay. Can you see that?
Yes, I can see that.
Okay.
Yeah, okay. I think let's get started. We have a pretty tight schedule today. Joseph, do you want to start?
All right. Still getting used to this Zoom overlay thing. I don't use it very often.
Yeah.
Okay. All right. So standalone containers are going to be a new concept that we're going to introduce into the containerizers and specifically the agents. So the concept behind standalone containers is that we want to be able to launch containers, but doing so directly through an agent API rather than going through launching a framework which connects to the master, which then has to talk to the agent, and then the agent has to launch a container that contains an executor, and then give that executor a task to then launch some like command line thing underneath. So standalone containers bypass most of this and just basically provision a container image and then launch command line task underneath. And the logic that's backing this is the same as other Mesos containers, just without the, or whereas the entry point is not an executor, it's just a command line task.
So, sorry, Joseph, before you get into some of the details, can you explain the motivation behind this?
Yeah, so I guess the direct motivation is to be able to launch what we would consider admin tasks on the agent. And these admin tasks would have, I guess, more complicated requirements than just some dependency that's already installed on the machine. Like we would want to launch an appc or a Docker container that could be some specific dependencies and then launch these on the agent before it connects to the master or before, without going through an offer cycle to launch these containers. So it's basically like treating the Mesos agent like the Docker runtime or Docker command line thing. And our first use case will be to launch a CSI plugin, or a container storage interface plugin, that will talk to the agent and provide storage resources.
So where do these standalone containers get their resources from? Or what resources? Maybe you get into that later on, and I should just wait till you explain it.
Yeah, I mean, we'll talk about it right now. So the resources right now are, well, this isn't actually implemented yet, but the goal for our minimum viable product is to have these resources just not be tracked anywhere. We would assume that when you start the agent, you will reserve some amount of resources for admin tasks, and the resources that you use in the standalone containers will just come from that reserved set. Basically, the number of resources on the physical machine or the virtual machine, minus the ones that are advertised to the Mesos master, are the ones that are reserved for other things on the agent.
So it's kind of a pool of resources that all standalone containers would pull from and sort of share as they came and went.
Yeah. The goal for later on is to use the same interface that we use to provide, or that we're going to add for resource providers. So the agent itself will be a resource provider of CPUs and memory and GPUs and storage. And to have that interface, it'll need to update the number of resources that the agent is advertising to the master every so often. And standalone containers can use roughly the same code path to say, I'm using like one CPU and some amount of memory, so that amount of CPU memory is no longer available for other tasks in Mesos, in the Mesos cluster.
Got it. So one last question before I keep blocking you from continuing. Since these aren't tasks, will we be able to do things like run the equivalent of task exec to get inside them if we want to debug what's going on with them?
Yeah, so these aren't tasks, but they are still containers. So you will be able to launch nested containers in them and nested container sessions, as long as we support, or as long as there is enough fiddling in the validation within the existing APIs to do so. I think that...
I think there should be. Yeah, the only thing you really need is a container ID.
Yeah.
Yeah.
I think there will be minimal changes to support this, or minimal changes required in order to support nested containers and nested container sessions. They should basically just work once we've implemented standalone containers in their API.
Cool, thanks.
All right, so as mentioned, standalone containers have no executors, no tasks. This also means that they don't have health checks, don't have kill policies, and status updates. So, I mean, these three things are implemented in the executor, and because we don't have an executor for standalone containers, these won't be supported right away. We might consider adding them later on because they might be needed, but for our MVP, it's not part of the MVP. So besides that, standalone containers share the same exact semantics as other Mesos containers. They use the Mesos containerizer. They will support UCR. They will support container images. And if you have some amount of isolators enabled, it'll go through the same isolation mechanics and the same isolation code path as other containers. We'll have to add a little bit, or we'll have to add a way of preventing old isolators from talking about standalone containers, because there might be some third-party isolators that depend on the executor field or the task fields, and those will not necessarily work off the bat or right off the box with standalone containers.
Yeah, Joseph, what's the plan on that? Like, are you going to introduce a like isolator capability, or just like another virtual function, like return a bool, say if it supports standalone container or not?
Yeah, I mean, both are viable approaches. I guess the way we want it to go in the long term is through some sort of enumerated capability.
Okay, yeah, I think that would be great. Otherwise, like we might have like too many virtual functions that that does not scale, I think. Yeah. Okay.
Mm-hmm. Yep. So far, we'll just have two capabilities, which is launch nested container and launch standalone container. Yeah, and the I guess the semantics behind each is a nested container has a container ID with the parent, and then a standalone container will just have more blank fields in the arguments that have passed into the isolator.
So, sorry, what's the, maybe you just said this and I missed it, but what's the motivation behind having two APIs instead of just consolidating on one? Well, like we've got launch nested container. Why now a new launch standalone container? Why not just have a launch container?
So we want to, we don't want to have a launch container because, well, when you launch a container directly on the agent, it is always going to be a standalone container. I'm not talking about nested containers here. So we're going to have a call for launch standalone containers and then one for launch nested containers.
Yeah, but I guess what I was saying is that if we had one API just called launch container, if you had a parent ID on your container ID, then it would automatically become a nested container that was being launched.
Yeah, I think that's an interesting point, but I think we already have like launch nested container, and I don't think we can change the name of that API. So that API has to be there for backwards compatibility. So I don't think it makes sense to hijack that API to support a launching standalone container. So we don't have a choice but adding a new API for that.
Okay, but there's no like difference in
there's no difference.
What the API would actually be doing.
Yeah.
There's just
no fundamental difference.
But that's basically all there is. The actual plan for this is fairly similar, although there are some differences in the return semantics for standalone containers versus nested containers. Standalone containers are meant as, or they are designed for the operator to use rather than for frameworks and tools. So the launch standalone container will be more of an idempotent launch, whereas launch nested containers, like if you give it the same ID, it'll fail, whereas when you launch the same ID in a standalone container, it will succeed.
So just one comment on the idempotency. You're saying like the launch standalone container is idempotent based on the ID or based on all the fields. Like for example, if I have the same ID but the next call I specify different command, different container info, what's the semantics there?
Yeah, so it's currently just based on the ID because I don't expect that we'll be saving most of the other fields in the agent.
Okay, I see. It'll be nice to clarify that, like the idempotency is only on the ID.
Yeah. It's this little comment. If the container with the same ID is already running.
Okay, I see. Got it.
So if it's already running, you allow it to keep running. and you just give a 202.
Yeah, so the idea is if the operator knows that they are changing a field and then they launch with the same ID, then if they get a 202, they know to first kill and then relaunch. This is primarily to support things like, if you were to launch a standalone container through a supervisor service like a Upstart or systemd, if they repeatedly launch, we'd expect those things to succeed.
Okay,
It seems a little strange to me, but okay. 202 just seems like a weird thing to get back if your next plan is to kill the container. But yeah,
If your next plan is what?
If the next, sorry, go ahead.
I'm a little confused about why you'd want it. What if your use case is launching these things under a supervisor, then an HTTP API doesn't seem like a natural interface for that. No, most things that launch processes under supervisors are going to be executing a command and like watching a PID, that kind of thing. So why did you end up with an HTTP API?
So we're going to have an HTTP API regardless of the, I guess, the final interface. Like there may be a CLI component after we've implemented these API. So the CLI could then be like a Mesos CI launch container. It could just look like a normal command line thing.
By the way, I just read your comment on the side there, and that answers my question about why the 202. So.
So James, I think like if you look at Docker, so Docker has a daemon and it provides a HTTP API, and Docker client is like, for example, Docker run is like a client that talks to that HTTP API, and in system unit you can specify like Docker run, things like that. I think it's the same model, essentially.
Yeah, I kind of get it. Maybe there's some background which I'm not really isn't kind of present in here. There's a lot of things that are similar. So, like, is this supposed to be analogous to the Kubernetes daemon sets, or is it supposed to be for developing? I guess I'm not really. I guess the use case for this isn't all that obvious to me.
So this can be used for development, but it's primarily aimed for running additional components alongside the agent, such as, there's like an existing demand for things like admin tasks in Mesos, where at the start of an agent, you would launch one or two extra things that would be like maybe a proxy to agent endpoints, or like some extra security features or database alongside it. This would be roughly the same thing, where we would launch a CSI plugin that is actually offering the storage resources of the agent, and we can't have, or in our newer model of resource providers with the agents, we'll need to have the CSI plugin launched alongside the agent outside of the resource offer cycle.
So that logically, that's the agent being a framework for a task that runs on the agent. That's one logical way of thinking about it.
Yeah, I think so. Like, just like I won't call it a framework because there's like no like offer cycles. It's like a very dumb like init system, I would say. Like just monitoring the health of the process and relaunch if it fails, things like that. It's a very simple way of doing like monitoring of a supervisor for a given container.
Did you guys consider doing something like that instead of having standalone container, having sort of a framework that is launched by the agent when it first starts, that gets the first set of offers to choose, so it can grab a bunch of resources to act as the resources?
Standalone containers are not necessarily, or they're not necessarily tied to a master component. The the end goal is that you would launch a Mesos agent and then launch a standalone container without having a master in the loop. So the master might not even be up when you're doing this.
Got it. So then,
But
then
you
it
have to
really
have
does
the agent, right?
Yeah, you have to have the agent.
but you don't have to have a master. I see. So then it makes it really look like what you were saying before, like a Docker D or something, where you can launch containers eventually.
Yeah, the reason, I mean, we can, like, for example, like for the one of the use case for CSI, I mean, the other alternative is like we just directly talking to Docker daemon for those CSI plugins. But we don't want to do that because we don't want to like strictly tie to Docker daemon and all the APIs. I don't want like strict tie to Docker daemon and then providing the abstraction layer in agent like makes more sense to me.
So then is this identical to just launching a container without offers? Because like in terms of the isolation, is the isolation still done by the agent?
Yeah.
The isolation is going through the exact same code path as when you launch a container normally.
Oh, I see. Okay. So, right. Okay, it's a little bit more obvious to me now. Thank you.
Yeah, so we recently refactored the Mesos containerizer so that it takes the same arguments for launching a command task or a default executor task or a nested container, or in this case, a standalone container. So all those go through the same code path.
So in terms of operator APIs and everything, standalone containers are visible through the same operator APIs as any other container. Is that right?
Yeah, there will be some fields that are going to be missing, of course. But if you go through like agent/containers, it should still be there. I'm not sure what the output would look like in agent state, but we'll have to add that as well.
Yeah, /containers, we have to maintain backwards compatibility. I don't think we even show like nested container in /containers. So we only show like top level executor containers to be backwards compatible. So either we add some parameter to the request, allow operator to specify, hey, I want to see all the containers, including nested container and standalone container. Otherwise, we have to use a different endpoint for that, just for the sake of like backwards compatibility.
Right. Questions?
Does that make sense to you, James?
Yeah, that makes sense. Thanks.
Okay. So where were we? Right. So the I guess continuing off on the API itself. So we've mentioned that the launch command for standalone containers is idempotent, primarily so that you can make the same call twice and expect both to succeed. As mentioned, we have resources that won't be accounted for in the master at this moment. I'm going to leave a giant to-do in the code when this stuff is up for review. But besides that, the actual fields here are identical to launch nested container. You've still got the container ID. We're not going to enforce any UUIDs in the container ID at this moment. Maybe it's because we want some, like, well, it could be a human readable ID instead of a UUID. Yeah. Besides that, we've got the command info and the resources and the container info. You want
So Joseph, it sounds like you can't tell the difference between a launch, a repeated launch, or just a ID collision.
Well, there are going to be different status code returns. The first, if you launch a standard container the first time, you'll get a 200. And if you do the same call again, you'll get a 202.
But if you launch a different container whose ID happens to collide, you would get a 202.
Yes.
Okay. You don't verify that the other fields are identical.
Yeah, so we're going to do that because when you restart the agent, standalone containers will still be recovered normally. But at this moment, we're not saving the other fields. We're not checkpointing them. the disk at all. So at that point, we just have the container ID for a standalone container. And if you try to relaunch it then, we had to be consistent.
Right. Okay.
Yeah, so we're not checkpointing these things at the moment because it's extra code, and we're not sure if it's necessary yet. But it's certainly doable to checkpoint all these other fields.
What happens when standalone containers use things like persistent volumes? Is that possible? Like, can you do that through here?
So non-compressible or non-shareable resources are going to be a bit more challenging for a standalone container to use. Mostly because these resources will still be shared to the master, or they'll still be advertised to the master. So it's really easy to get a collision if something launches a framework or some other task through the normal offer cycle, and it lands on the same persistent volume or the same port or something. So what we're going to do there is, if you're going to use a volume or a port on a standalone container or some other non-shareable resource, then you should just exclude those from the agent's resources at start.
Yeah, I think persistent volume is going to be a bit challenging until we reach a state where we can update the agent resources dynamically. Yeah, otherwise, like, it will be a conflict. I say some framework launches has using the same persistent volume as the standalone container, and then suddenly you have two containers just trying to simultaneously access to the same volume, which might break some of the code. Yeah, as Joseph mentioned, like, compressible resources is okay, but non-compressible resources, we probably need to disallow that initially. Or maybe just say resources here in the standalone container is only for CPU and memory, because that maybe disk, because that's something we care about, and the rest probably don't care about. Just disallow that as a start.
Yeah, for MVP, we might just go through that route. Have to think about how we're going to do this a little bit more.
Yeah, that's a good feedback. We should think about that more, especially for persistent volumes.
Yeah, got a note here already. Okay, so for other APIs that we're going to add, we're going to have a wait command so that basically a supervisor or an external service can know when a standalone container exits or fails. This is primarily so that the supervisor of the standalone container will know to relaunch necessary. We don't expect all standalone containers to be long-lived, but if they have to be, then we have to provide a way for them to be notified on exit.
Joseph, just one question here. So if the container terminates, if we call wait, it will still return the exit code. Is that correct?
Wait, if it terminates?
Yeah.
Like that would be considered an exit or a fail.
Exit or fail. Okay, but what if, like, I call wait after the container has been terminated? Will I still receive like 200 OK? Because that's a semantic for nested container. I just want to make sure, like, we have consistent semantics here.
Yeah, so I guess we want this to have roughly the same semantics as a wait PID on a normal process ID. So we'll keep this container ID around until somebody calls wait on that container ID.
So we're going to keep the checkpoint directory forever?
Only until the first standalone container. And then after that, the checkpoint and stuff will be added to the normal GC cycle.
Yeah, so you'll force it to be there until someone calls wait so they can get the exit status. And then after it's been waited on, exit status been returned, then you can add it to the GC list.
Yeah, but that's kind of little different than like a wait PID, because I think, like, you have two components involved. Well, if the first wait, you don't know if it's successful or not, and then you call the second wait, what if the first wait did succeed and then like kind of GC the directory, the second wait is going to fail. Yeah, I don't know like what's the, I mean, from the caller, then it's very kind of like then the caller don't have a way to get the exit code, right? So that's kind of unfortunate.
First and the second call.
So so the caller like issue. So like say caller launched the standalone container and then terminates, the container terminates, and then the caller call the first wait, and somehow agent crashes before the response of that wait return to the client. Okay, now agent restart recover, and then things you like the agent already processed the wait, so that direction might be GC'd, and then but the client don't know the result yet, the client will call wait again, and then the second wait don't have a result because the directory has the checkpoint directory has the exit code already being removed or GC'd. So how does the client find out the exit code for that container?
Yeah, I mean, in that case, well, at least in the current design, we would return a 404 on the second call if we no longer know what the agent.
Yeah, but that's not ideal, right? So I think like
Yeah,
what we
it's not
did.
ideal, but I'm not sure if we want to have a three-way handshake on this call.
No, you don't have to. I think the way we handle that in nested container is we have another call called remove, which kind of like it's kind of like another call to indicate that it's safe to remove all the artifacts associated with that container, including the exit code. So if you don't know the result of a wait, you should not call remove. But if you do know the result of the wait, then you can safely call remove to remove all these artifacts that associated with that container.
Yeah, we added that later. It wasn't in the original launch nested container design, but we added it later for the health check work that Gaston was doing.
Yeah, is remove really intended for use by operators though, or is that just meant for the health checker?
Yeah, it sounded like it was mostly for health checks when we have a long-lived top-level container and then infinite child containers.
Yeah, but the remove is kind of an indication on the fact that the client won't be able to get the exit code anymore. Otherwise, like we have a GC problem because we don't know when it's safe to GC that checkpoint directory for the exit code.
Mm-hmm.
I think we should think more on this, and I do believe that a remove is necessary for this case. And yeah, but we can chat more on this. I think we should keep moving. I think we only have like 28 minutes. We have another presentation queued up.
Okay.
So I have a quick question. Why aren't there executors in these containers?
Sorry, what was the question? Why not?
There aren't going to be executors in these containers. That's primarily because the executor would have to register with the agent and be associated with a framework, and we just don't have a framework in this case.
Yeah, but we can imagine putting some wrapper around it that did health checks and some of these other things, like a stripped down executor or something. I think maybe that's what your point is more, James.
Well, yeah, because I guess originally it wasn't clear to me originally that the agent had to be running for these things to launch. So that if the agent is running, then you have a full agent stack on the host, so you have the default executors. It seems like you have almost everything you need to make these basically the same as regular containers, in which case, if they are the same as regular containers, then it seems like a good thing. There's only one, there's less diversity in terms of how containers look and feel, but I haven't really thought through the full implications of that.
Yeah, I think that's an interesting point. Like maybe we can do that. We just need to make the default executor or like command executors like a registration part optional. So if it's
yeah, the other
it would also it would also rationalize why there's two separate calls for the launch container. Launch standalone container, launch nested container would actually look significantly different at that point too, right?
Mm-hmm. Yeah, and we also wouldn't know who to send status updates to, or where to report these health check results.
But it seems like if you're running like a CSI service, maybe you do want that to be health checked, right? Because this thing never becomes healthy. Like you want it to be. I think the concept of health checks makes as much sense in the standalone container world as it does in the framework managed container world.
Yeah, I think health check is not that difficult. The client can do health check by just hitting some HTTP endpoint.
Yeah, they can
but just
launch
like
the container in the standalone container.
yeah, just a matter of like reusing some of the code in Mesos. Yeah, I think that's a good point that we might want to think about how to.
Maybe you could have like a designated, well-known framework ID constant that is the framework that this stuff gets.
Well, we might add a subset of. Well, we might add a health check independently of executors inside standalone containers, because it wouldn't be too difficult to like launch an additional process inside a container after we've launched it.
Yeah, I could imagine the wait call returning a streaming response that you would get health check events on, for example.
Mm-hmm.
You could always just internally use the launch nested container API to launch a new process inside there.
Yeah, which is exactly what a health check or some health checks will do.
Okay, we should probably move on, like G said.
Yeah, I think we should move on. And do you have anything else? Like, can you scroll down? Any okay. What kill? Okay.
The kill should be relatively straightforward. We're just sending a signal to the container so that we can get rid of it.
Mm-hmm.
I haven't exactly decided if we want to make waiting after a kill required. Because I guess if you specify a signal there, it might actually not be a kill. You could specify any kind of signal to a container, and that will not necessarily terminate the container.
Mm-hmm.
Okay, besides that, at some point, if we have a service within Mesos itself that launches standalone containers, we're going to have some sort of wrapper in there. But if we have, say, an internal component inside Mesos that's launched standalone containers, these will still go through the operator API just like any other caller. So they'll have the same restrictions as everyone else. That's basically all we have at the moment for this design.
Would executors be able to, so executors can launch standalone containers?
Yeah, technically anyone could launch a standalone container if they have the correct ACLs and authorization.
Okay, so an executor that gets allocated a certain amount of resources, in theory, if I'm not satisfied with those resources, I can just go and launch a bunch of standalone containers.
Yeah, I think then the point is, why do you need to launch a standalone container versus like nested container in that case?
Yeah, I mean, I guess executors are semi-trusted anyway, so it's probably fine in practice.
I don't know how trusted they are necessarily. You can specify your own custom executor whenever you launch a task or whenever you launch a framework.
Yeah, and we definitely wouldn't want our default executor in Mesos to be launching standalone containers all over the place. Those would be harder to manage compared to a nested container.
Okay, so I think we are out of time, and thanks for the presentation, Joseph. If you guys have any comments or suggestions, please feel free to talk to Joseph over Slack or emails. I think we should move to the next presentation. Okay, let's move to the next presentation. So JP is going to demonstrate the network port isolator that he's been working on recently.
Make sure that you make the least time.
Okay, I don't actually have a demo prepared, but let me share my screen. I just have I just go through the design doc because it's relatively straightforward. That one. Other screen. Man,
I know how these questions.
It's not showing me the right screen.
The other one was like you randomly should you like.
Yeah, we can see your screen. I see the doc.
Oh, you can see the right screen? Because it's
Yes, I see the doc.
Yeah, we see the
okay.
we see the doc. Yeah.
All right, cool. Because I'm not
it's showing the whole screen, but we can see the doc in the middle of it.
That's fine. Okay, so I guess the motivation for this was we run all our clusters on the host network, and we allocate ports, and we expect user tasks to use the ports that they allocated. Every now and then, we have problems, or a user task has problems because it doesn't follow the contract, because it's not always straightforward to do, and people forget, and things mostly seem to work. And so you'll have tasks which take a port, start listening on a port that they don't have resources for, and everything will sort of work. But then they'll get some kind of weird problems on health checks that they don't understand. It's not right, and someone has to debug it for them. From a security point of view, if you have tasks which for where there's no technical restriction on which ports they can listen to, then there's lots of possibilities where tasks that aren't trusted are able to intercept traffic from other tasks, and lots of things that can go wrong if you start looking at it with a security hat on. So I basically the idea is I looked into how various socket tools work, and the answers are not all that thrilling. Pretty much what we want to do is we want to make sure that each container only listens on ports for which it holds resources. There's no real good kernel APIs for this. Basically, what you have to do is find all the processes in the C group, find all the sockets from all the processes in the C group, and then match those sockets up with the sockets, the set of listening sockets which you've obtained from Netlink. So this is like an order n queued or something ridiculous like that, because you end up having to scan procfd for every open file descriptor. So we're doing the same thing that isolators like the disk, the POSIX disk isolator do. We basically, in the background, we periodically collect all the information we need, and then we resolve it against the list of containers which we know about. There's a code.
So this is more of an enforcement type thing, meaning they might try and just open random ports or connections on random ports, and if they do, we have something running in the background to kill that somehow. Is that the idea?
Yes. Yep, that's correct. So if we find that a process in your container is listening on a port for which it doesn't hold resources, then we'll raise a container limitation, and then the containerizer will come back and kill you.
It'll kill the whole task.
Yeah, it'll kill the whole task.
So what about ephemeral ports? Like if I have a process listen on a port on the ephemeral port range, are you going to enforce that as well?
Yes.
Okay. But we don't send resources to ephemeral ports. Like, how do you know this is like a wrong port that process shouldn't listen on?
So the contract, so it's actually an extra mode. So there's a configuration knob which somewhat addresses that. In general, my view is that we should be strict, and that processes should only be allowed to listen on sockets for which they hold resources. Blanket rule. Now, libprocess doesn't follow this rule. So anytime you have a built-in Mesos executor that uses libprocess opens a port. It just listens on a port. So we have a mode which in this doc is called container ports watch resources only, but has a slightly more obvious name in the current patch series, which I'll guide for. which is okay. It's not here on the front.
Yeah.
It's something like agent ports. Check agent port range only. So if you enable this option, then what we do is we only verify ports that are being listened to within the range of ports that the agent is advertising as resources. So what that means in practice is that any container can listen on any port they want as long as it's not within the agent's port range.
I see. So you have an additional flag. Is there any use case for for this flag to be off?
Yes. The use case for this flag to be off is if you have a custom executor that uses the HTTP API and you're concerned about security.
Oh, I see. Got it. Okay.
So if you have like my executor is HTTP API, so doesn't listen on any ports. It only goes outbound to the agent. We really don't want user containers listening on arbitrary ports. We think that's generally a bad idea, and we want to give strong feedback to the users when they get it wrong.
Okay, sounds good. Yeah, that makes sense.
So it's actually the actual algorithm as I described is fairly inefficient, but there is a kernel patch. There's a kernel patch here. So thank you to the Verizon kernel guys. Thank you, Sasha. So this is currently in NetDev and the NetNext kernel. What this does is it provides the class ID from the netlink API. So that means that we'll be able to make this same mechanism work efficiently. And the way that will work is you apply the net class C group isolator, and you apply this network ports isolator. Then when the network ports isolator uses the netlink interface to obtain the listening sockets, each listening socket will be tagged with its class ID. Then we can use the class ID to find the C group, and the C group, once we have the C group, then we know the resources straight away. So all this POC-FD scanning will not be necessary once we get all that.
Lined up. So James, I have a question on this. So are you saying that the net class ID will be a resources in that case that the framework will set on each container?
They won't be in the resources. If you're using the net class isolator, then what we would do is we would do something like starting with your container ID, we would find the C group, we would look in the C group to find the net class.
Oh, I see. So just like directly looking to C group to find out the class ID.
Yeah, and then so we basically, when we get containers, we go poke around in the C groups to find the class ID. So then we maintain a in-memory mapping of container ID to class ID.
Okay, I see. Another question is is there a way to detect this kernel feature so that the isolator can be adapted so for example, if the kernel feature is there, using that way, otherwise using the old way?
Yeah, we'll be able to do that. Basically, what will happen is, I need to do a patch to libnl3 to pump through the APIs. But basically, what will happen is we'll get the socket info back from the sockdiags netlink interface, and either the class ID will be populated or it'll be 0. So if it's 0, then we'll have to do it the old way. If it's not, then we can do it the new way.
Okay, got it. Sorry, I have another question. So regarding without this kernel patch, you're going to do a polling on the socket diagnosis information. I think my experience this kind of very slow, especially if you have a container that has like 1 million connections. Do you have a polling interval that you can tune, or how do you make that? I mean, it's
there's a polling interval, container ports watch interval. So just like the container disk watch interval. So
Oh, I see.
It's
Got it.
pretty much modeled on the, the interface is very much modeled on the POSIX disk isolator.
Okay, sounds good. Okay, makes sense.
So that's kind of it. I've been going through with Chan, who's been giving me some great feedback. We have a few more things to work through. One problem that he pointed out last night is that the resources of the ports in the isolators update method are attributed to the executives container, whereas we really need to track them on each nested container. So they need to do some more thinking and experimenting about how to solve that.
Yeah, I think that's a good catch. Yeah.
Can you say that again? I didn't quite follow.
When the isolator gets the update callback, the containerizer will aggregate all the resources and apply them to the executives container. This is when you have a tree of nested containers, which means that all the ports for all the nested containers will at that point will be then attributed to the executor container. What we want is for each ports to be, we need to know the ports for each nested container kind of discretely. And we can know that when containers get launched, but I just haven't looked at this in detail yet, but I don't think there's a good way to know that when you're recovering.
Yeah.
Yeah, I think maybe like it's okay because I think because you don't have like a nested container that has a separate network, so it's all on the host network. Like just having a check on the top level container should be sufficient. Maybe I'm not exactly.
Yeah, and it's not that satisfying. I think it might be the only thing that can work, but I think it would be more satisfying to be able to enforce that. Container A, which asks for port 32, actually uses port 32 rather than container B, container B, which asks for port 40, but maybe ended up using port 32.
Yeah, I think the tricky part here is like right now we don't support like a nested container specifying resources. That's kind of like a limitation at the moment. And the reason we don't do that initially is because for some of the resources, it's more complicated. For example, for CPUs, if you do allow nested container to specify CPUs, how do you structure the C group CPU hierarchy? Do you need to extract the CPU shares from the top level container or not? We don't have those answers. And also, I think
also at the moment they don't even go through an offer cycle, so they don't have the opportunity to request resources.
Well, you can say like a resource coming from executor, like all the executors should request those resources. I think that sounds fine. Or the task for that executor container can request resources, but the fact that you want to deal with this nested structure for C groups like CPU memory, it's going to be complicated and we don't know the answer. So that's the reason we don't do that yet. But it would be great to think about that.
This thing on.
I had a task test in this patch series, but I really need to spend some more time to make it a bit more sophisticated so I can understand these issues a lot better.
Yeah, that sounds good. Thanks, James. Okay. James, do you have anything else?
I don't really have anything else on the nested containers. I have a design doc which I'm going to post around about adding PAM support to the containerizer.
Yes. Can we do that? Yeah, I think like let's do the PAM discussion next time, next working group meeting. Does that make sense? I think we all have like 6 minutes.
I'll be happy to do that.
Okay, let's do the PAM discussion next week. Next time in 2 weeks, and I encourage folks to do some like background digging on that. Because
which discussion? I didn't understand what you said. Sorry.
So James has a design doc for pluggable or authentication module support, PAM support for Mesos, and we're gonna have a discussion on that.
Got it.
And James, it will be great that you can provide some background during the sync next time, because I don't think many people understand what that is, or like most people don't have the context. So it'd be great to have some background introduction on what that is and what things it's trying to do. That would be really useful for others.
Okay, I can add some more info to the design doc too, just to make it.
Oh, yeah, thanks. That
Yeah.
would be great. Okay, so I think we are on time. Anything else? Okay, so I think we're kind of early. Thanks everyone for joining the meeting and do the presentation. Thanks, and we will see you in 2 weeks. Thank you.
Bye.
So,
See you guys.
Thanks, guys.
Bye.
Bye.